Hi, in this video, we're going to be reviewing the four most common mathematical relationships we find in physics. So here are the four relationships. We have directly proportional, inversely proportional, quadratic, and inverse square. And I have alongside here their word definitions and their math definitions. So you're welcome to look at the definitions here, but I want to actually see some examples of these. So let's look at some example data sets. So let's look at some of these data sets here. Here's the first data set. We've got 4 data points. You need at least 4 data points to really be able to tell if there's a mathematical relationship. And so we're going to compare data points. You can pick any 2 data points. It helps if they're far enough away from each other, they're separated a little bit. So we're going to pick data point x1, y1, and then data point x2, y2. And what we want to see is, does the proportion or ratio of the y values equal that of the x values? If they're equal, that means it's a directly proportional relationship. So I'm going to pick for our 2 data points here, I'm going to pick 5 and 13.5 and 15 and 40.3. Those are going to be my 2 data points. And I want to see, as I increase the x, how does the y value change? So the y value changes by this ratio. We take the y2 over y1, 40.3 over 13.5. That's a ratio of 2.99. If we're testing it for directly proportional relationship, we need to do x2 over x1 to see what that ratio is, and that's 15 over 5, and that's 3. These two values are nearly equal, and so that tells me this data is in a directly proportional relationship. Now I could test this again by picking 2 other data points and seeing what the ratio between those two are. Sometimes you have to do it multiple times with different data to make sure that you are, you do have a directly proportional relationship. Let's look at the second data set here. We've got some new numbers, and this time I'm going to test it again for directly proportional because I see that as the x value is going up, the y value is also going up. 4, 11, 21, 3, 24, 88. So it's going up. They're both going up. So I know it's either going to be directly proportional or quadratic. To figure out which is which, we again do the y2 over y1. I'm going to pick this time 21 and 88.2, and then I'm going to pick my first data point here, 4 and 3.2. All right, so the ratio of the y values there, 88.2 over 3.2 is 27.6. So the y value has increased by a factor of 27.6. The x value, if you just do a straight up x2 over x1, that's 21 over 4. And that's an increase of 5.25. So you increase the x value by 5.25, and the y value goes up by 27.6. That's a lot more. So it's not directly proportional because these two proportions are not equal. So we can test to see if it's quadratic by taking this 21 over 4 and squaring it. And if we do that, 5.25 squared is 27.6. And will you look at that? Those are equal. So if you square the x value, then you get the y change. And so that tells me that this is a quadratic relationship. Whatever you do to the x value, you square it, and that's how the y value changes. So this is for directly proportional and quadratic. Let's look at another example though. This time, as you increase the x value, the y value goes down. So we're going higher x values, but the y value is getting lower and lower. So again, for inverse relationships, we're going to do the same kind of test method where we're going to pick 2 data points and see what the ratio is between them. But the difference this time is for inverse relationships, you must check to see that the inverse ratios are related to each other. So instead of y2 over y1, we invert it. And so we say y1 over y2 is equal to x2 over x1. So we've inverted the ratio of the y value. And the same thing for inverse square, y1 over y2 is equal to x2 over x1 squared. So they're inverted ratios. One is squared, one is not. So for this particular example, I'm going to pick as my data points the first data point here, 7 and 10.7, and then my third data point here, 18 and 4.2. So my y1 value, don't get this mixed up, it's easy because we've inverted it. y1 is 10.7, y2 is 4.2. that's a ratio of 2.5. And if I do the x2 over x1, it's inverted. 18 over 7, that's 2.6. These two are nearly equal, and so this tells me we have an inversely proportional relationship. There's no need for a square in this one. And then finally, let's look at one last example. So we have another data table here where the x values are going up, the y values are going down, and so this is an inverse relationship. Is it inversely proportional or inverse square? So again, to do that, we take the inverted y1 over y2 ratio. This time I'm doing my first data point and my third data point again. Just picking any two, doesn't matter. So that ratio is 7.4. When I do the inversely proportional test, x2 over x1, that's 14 over 5. That's 2.8. All right, that's not the same as 7.4. So what happens if I square that? 14 over 5 squared, 2.8 squared, 7.8. So these two values are much closer. So we're going to say that this is an inverse square relationship. Now the numbers are not going to be perfect for real life measurements that you make in a lab. We're looking for what patterns emerge as we collect data. Now as you get more and more precise with your data, the numbers will be more and more closer. But in this case, we're looking for just something that's pretty nearby. So that's all I've got for you in this video.